Okay, we're starting Unit 4, Lesson 1 with this video, and this unit is going to take place out of Chapter 12 of the textbook. And Unit 1 is about trigonometric functions and right angles. And in general, Unit 4 is going to be all about trig functions and triangle relationships. So we have a mathematical practice that we're going to focus on with this lesson, which is practice number 6, attending to precision. In the past, we've learned how to use the Pythagorean theorem, a squared plus b squared equals c squared, to help us figure out side lengths of different right triangles. And in this lesson, we're going to find values of trig functions for acute angles, and then use trig functions to help us find the side lengths and angle measures of right triangles. Trigonometry is a new vocab word: trigonometric ratio, trigonometric function, sine, cosine, tangent, cosecant, secant, cotangent, reciprocal functions, inverse sine. There's obviously a lot of vocab here: inverse cosine, inverse tangent, angle of elevation, angle of depression. You can see there's a whole lot of vocabulary that we're going to be talking about in this lesson. So our first key concept is the explanation of what the trig functions are and what they look like in a right triangle. So basically what we're going to do is we're going to pick one of the angles in a triangle that's not the right angle. So in this picture right here, we're using this angle, and it's called angle theta. This symbol right here that you see, that's pronounced theta. Let me write the word out just to see how you can, that's the way the word is spelled, to talk about angle theta. So if we want to find the sine of angle theta, it's the opposite side divided by the hypotenuse. So op stands for opposite side, adj stands for adjacent side. Adjacent means next to the angle, and the hypotenuse is abbreviated hyp. The hypotenuse is always the side that is across from the right angle. So if we see this right angle, we go across from it 5. This longest side is the hypotenuse. On this triangle, the adjacent side, the side that's closest to angle theta, is this side right here, 3. And if we go opposite from this angle across the triangle, we hit 4. This is the opposite side. So for this triangle, the sine would be opposite over hypotenuse. That would be the opposite, 4 divided by 5. The cosine is adjacent over hypotenuse, so that would be 3 divided by 5. Tangent relationship is opposite over adjacent, so that's 4 over 3. And then we have these things called cosecant, secant, and cotangent, which are just the reciprocals of the things that they are across from. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And you just flip all those fractions over. So if you have 4 over 5 for sine, cosecant would be 5 over 4. 3 over 5 for cosine, 5 over 3 for secant, and so forth. These relationships are really important. It's important that you spend time to memorize what they are, that sine is opposite over hypotenuse. In class, I'll give you guys an acronym to help you remember this. But this is super, super important, and you really have to know this stuff if you want to ever be okay with understanding what trig ratios are. So for our first example, we're going to look at a triangle where we know all the sides, and we just have to find the values of the 6 trig functions for angle G. So we're thinking about this angle over here. Right here. So it says for this triangle, the leg opposite angle G, so opposite angle G would be 24. And the adjacent one, the side that's closest to it, that's not the hypotenuse, is 32. And 40 is the hypotenuse because it's across from the right angle. So we're going to use opposite side is 24, adjacent side is 32, and the hypotenuse is 40. And now we're going to write each of our 6 ratios. So our first ratio, sine, is opposite over hypotenuse, so that's 24 over 40, which reduces to 3/5. Cosine is adjacent over hypotenuse, so 32 over 40, and that reduces to 4/5. And then tangent is opposite over adjacent, so 24 divided by 32, and that reduces to 3/4. And then cotangent is the reciprocal of tangent, so instead of 3/4 we'd have 4/3. Cosecant is the reciprocal of sine, so instead of 3/5 we'd have 5/3. And secant is the reciprocal of cosine, so instead of 4/5 we have 5 over 4. And so those simplified values, it's important that you simplify these ratios, are the 6 answers to this question. All right, we have got a check your progress problem here, which I'm going to ask you guys to solve. I'm not going to show the answer to this one. We'll talk about it in class, though. It says find the value of the 6 trig functions for angle A. So we see again, angle A is over here. We've got our 3 sides. Look between the choices, and you're going to need to do your work on a sheet of paper. And this is going to be part of the classwork that you turn in. I'm not going to show the answer. I'm just going to jump on to example 2 now. Okay, for example 2, we're finding trig ratios. It says in a right triangle, angle A is acute, and the tangent of A is 5 over 3. We need to find the value of cosecant A. So the process for this is the first thing we're going to need to do is draw a triangle and label one of these smaller angles because it's acute. Label an angle that's less than 90 degrees as angle A. And you can label the other 2 angles as whatever letters. You can use B and C if you want to make it simple, A, B, C, or you can use other letters if you like. Then you know that the tangent of your angle is opposite over adjacent. So that means if they tell you the tangent of A is 5 over 3, the opposite side is 5, so we're going opposite A is 5, and adjacent to A would be 3. So this is 3. So clearly the side that we don't know from this right now is this side, the longest side that's opposite the right angle, so we don't know the hypotenuse. So now step 2 is that we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. Remember, A and B are the 2 shorter sides, and C is always the hypotenuse in a right triangle. So we know 3 and 5, we're going to plug them in, square them, we get 34. It's c squared, square root both sides, and so our answer is the square root of 34. So now that we know all 3 sides, we need to find the cosecant of A. So we need to remember that cosecant is the reciprocal of sine. So instead of opposite over hypotenuse, we have hypotenuse over opposite. So we're going to plug in the sides that we know. The hypotenuse is the square root of 34 divided by 5. And that's our answer for cosecant A. Okay, we're going to do a check your progress problem now. We know if sine of b is 2/3, we're going to find the value of cosine of b. So again, I'm not going to show the answer. Make sure you follow the steps of example 2, draw a triangle, label the sides, figure out the missing side using the Pythagorean theorem, and then figure out what cosine of this angle would be. Again, write this down on your notes. It's something you're going to turn in for classwork. Okay, our next key concept are the trig values for special angles. And there's 2 kinds of special triangles. The first one is called a 30, 60, 90 because it has angle measures of 30 degrees, 60 degrees, and 90 degrees in the triangle. And the second one is called a 45, 45, 90 because 2 angles are 45 degrees and the third angle is 90 degrees. And these relationships right here are something that's very important that's going to show up repeatedly over and over again in math classes after Algebra 2. And your teacher's just going to expect that you know these things. So copy these diagrams down in your notes, copy these relationships down in your notes, spend some time looking over them. They're really important that you remember. All right, example 3, we're going to find the missing side, and we're given an angle and a side on this triangle. It says use a trigonometric function to find the value of x and then round to the nearest tenth if necessary. So what you want to do first is look at our angle. We have an angle of 60 degrees, and we know the side that is opposite from it is x, and we know this 12 right here is across from the right angle, so that's the hypotenuse. So we know the opposite side to our angle, and we know the hypotenuse. So because we know the opposite side and the hypotenuse, we're going to be using the sine function, the sine ratio. So we know sine is opposite over hypotenuse. We know our angle is 60 degrees. We plug in our sides. The opposite side is x, the hypotenuse is 12. Within our calculator, we know, or we can think back to the relationships that we just copied down, because this 60 degrees is one of those special angles. The sine of 60 is the square root of 3 over 2. So the process right now, once you have the square root of 3 over 2 equals x over 12, is we're just going to cross multiply and then solve for x, and we get 6 root 3 is x, which is about 10.4. And honestly, I'm more happy with 6 square root 3 as an answer than 10.4, but either one of these would be acceptable for this problem. All right, we've got to check your progress problem now. This is another one you're going to need to copy down and put in your notes as part of your classwork. So it says write an equation involving sine, cosine, or tangent that can be used to find the value of x. Then solve the equation and round to the nearest tenth. So we've got a 60-degree angle, one side that's 5 and one side that's x. So work through this problem. Again, I'm not going to be showing the answer. When you get your answer, make sure you have work. Make sure you tell me the letter that you choose on your paper that you're going to turn in for classwork. All right, example 4. And again, we're going to be finding a missing sideline. This is kind of like a real-world problem. It says to calculate the height of a building, Joel walked 200 feet from the base of the building and used an inclinometer, I don't know how to say that word, to measure the angle from his eye to the top of the building. If Joel's eye level is at 6 feet, what is the distance from the top of the building to Joel's eye? So we want to find from the top of the building straight down to Joel's eye, that distance. Hopefully you can see on this triangle that distance side would be the hypotenuse of the triangle, since the right angle would be sitting down in here. So, okay, let's go back. The sides that we know, because Joel walked 200 feet away, this side right here is 200 feet. And it tells us that our angle is 76 degrees. When Joel looks up to the top of the building, his eye line is making a 76-degree angle. So we know this side that's 200, we know this side is D. So we have to figure out which, is this the side that's opposite the angle? Is it adjacent? Is it next to the angle? Or is this the hypotenuse? Where's the hypotenuse, etc.? So moving forward, we can see that the 200 side was the adjacent side, and D, obviously, like I said, was the hypotenuse. So when we have adjacent and hypotenuse, we're using cosine. So we have cosine of 76 equals D over 200, or 200 over D. We're going to cross multiply, and that will end up giving us D equals 200 divided by cosine 76. So 76 degrees is not one of our special angles, so that's something we just have to plug in the calculator. So when we do that, we're going to get a value of 826.7. So that tells us that the distance from the top of the building to Joel's eyes is about 826.7 feet, or about 827 feet if you round to the nearest whole foot. Okay, we've got to check your progress problem. I'm almost out of video time, so make sure you draw a picture, recreate it just like example 4, work through it, pick your answer, put it on your notes. It's part of another problem that you're going to have to turn in today. All right, we're going to pick up with the rest of the lesson in the next video.